Hello and welcome to Mellow Labs. On today's episode, I need to let you in on a little bit of a secret. For the past 2 years, I have been working on my very own lab bench power supply, and honestly, I'm surprised I didn't spill the beans about it sooner. I told all of my Patreon supporters about it, but that's because they know about every single secret project I'm working on. So if that's something that interests you and you'd like to support the channel, you know where to find the link. So why did I build it? I've been using the same lab bench power supply since about 2020, and honestly, it does the job. I can adjust the voltage and I can adjust the current, and that's kind of it. After a while, I started getting a little bit more advanced and I started wanting some nicer features like a second channel, being able to turn my output on and off, being able to minutely adjust the voltages, some voltage presets for like commonly used voltages. That would be nice. And you know, I had all those features in mind. Eventually I thought, okay, I'll go out and buy myself a new one. So I had all the features, I had a set price point, I went online and decided that I can't afford anything that is out there. So I thought, okay, how hard can it be to actually make my own lab bench power supply? Turns out it's not that hard. The problem is, it's kind of like looking at a blank canvas. Where do you start? Because like you can get all the parts, but then like, how do they talk to each other, right? So after a long time, this is what I've ended up with. This is version 1. It's not the prettiest looking thing, but it has all of the features I want in my lab bench power supply. And honestly, I've had this running for like 2 months. I love it so much. Let me go over the features. The first thing you'll notice is that I have a touch screen. It shows my voltage, my amps, and then at the bottom, I have presets for my commonly used voltages like 3.3 volts, 5 volts, 12 volts, and then I've got amps, 1, 2, 5, and the same on the other side. And you can obviously adjust those for whatever voltages you'd like. I have nice big mechanical switches to turn my outputs on and off. I have knobs that let me adjust the voltages down to one individual digit. I have, you know, regular banana connectors so that I can plug in my wires and use them that way. But the killer feature that this has that no other lab bench power supply I could find has, retractable cables. I can just pull this out, attach to whatever I need to attach to, and then when I'm done, it just takes the cable and sucks it back in. I don't have to deal with this cable just like laying around or hanging somewhere. Very annoying. This, pull out, put back in, love it. So yeah, this currently has every single feature that I want in my lab bench power supply. However, it does have some issues. Number one, the touchscreen, because this is an ESP32 cheap yellow display and it's running with a Raspberry Pi Pico, don't worry, I'll explain the stack later. It's not the greatest. You have to like hold down the preset button in order for it to register because of a weird update thing. So you either have to hold it down or press it multiple times. Very annoying. It's not very quick to update either when you're actually, you know, going up and down in voltages. Second of all, it's huge. It's just like way too big. It's mostly just because I didn't put too much effort into actually optimizing the insides of it. So there's a lot of wasted space. So that's what we're doing today. I'm going to open this up, spread it out, and tell you about all of the electronics that are on the inside. But before we do that, here's a quick message from today's sponsor. JLCPCB has exactly what you're looking for, whether you're a beginner trying to make your very first PCB or a professional looking for more advanced options. JLCPCB has you covered. Need a simple board just to bring an idea to life? They can do that. Need something a little more serious, like a transparent flexible PCB with aluminum backing and V-Rin pad for space saving and an ENIG finish? Well, JLCPCB can handle that too. Getting started is super easy. Just click and drag your Gerber files into jlcpcb.com, select what options you'd like to use, and you get an instant quote. Now I know all of that might sound really expensive, but it really isn't. Because of JLCPCB's large scale, they can bring the savings down to you, and they pretty much always have some kind of deals or coupons going on. Like right now, you can get $30 off of a 6-layer PCB, which brings the starting price down to just $2. And if you're a new user and you click the link in my description, you can get $123 in new user coupons, which makes your first few routing mistakes a lot less painful. JLCPCB does everything in-house with strict quality control at every step, and you can see that progress in your dashboard as you're waiting for your order. And for more complex boards, they'll even x-ray them and send you the images so you can see that everything is placed correctly as it should be. Check out the links in my description, and when you think PCB, think JLCPCB. Easy, affordable, and reliable. This all looked a lot neater when it was in the box. Right, I suppose I should probably explain what's going on here. So I'm using a 24 volt 10 amp power supply, which I recovered from my old Ender 3 Pro, along with this power connector. And don't worry, I've disconnected the AC right now. These two here are the power supply modules, which are specifically the XY6020L version 3. Now, when I first spec'd this build, I kind of wanted to build an overkill power supply. So these individually can supply 60 volts at 20 amps. Unfortunately, they are kind of just fancy step-down converters, so they can only step down the voltage coming in from the power supply, so they're limited to 24 volts at 10 amps. But theoretically, if I wanted to upgrade the power supply in the future, I could get more out of them. I don't think I'm going to do that because I'd have to upgrade all of these cable because these are all rated for 10 amps. Yeah, I just don't feel like doing that right now, so it's probably going to remain 24 volts. Also, I don't really see myself using more than that in any project I'm working on. Now, when you first get these modules, they also come with like a little interface screen, a little knob, so you can actually control them. Unfortunately, it kind of sucks. And after a while, I discovered that you can actually buy like Bluetooth modules for these because they have a built-in UART port on them. And then I discovered that somebody posted the communication protocol over on GitHub. So what you can actually do is control these with something like a Raspberry Pi Pico, an Arduino, an ESP32. And that kind of sent me down a rabbit hole because I realized that I can create my very own interface and have it look like whatever I want it to. And then that's how the 2 years went by without me making much progress. Eventually, I kind of went, okay, screw it, I need to do something. So I had an ESP32 cheap yellow display from a previous project, and I was like, okay, surely I can use this. Unfortunately, this has only one UART port, so I could control one of these, but not both of them. Eventually, I was like, okay, well, I also want to use like buttons and switches and things, and I can't connect all those to the cheap yellow display, so I involved the Raspberry Pi Pico. The Raspberry Pi Pico only has 2 UART ports, so I can control both of the power supply, but to talk to the screen, I'm having to use a programmable GPIO thing, which pretends to be UART, which works, but like I showed earlier, it's a little bit slow. But theoretically, it all works. Now, the last thing I want to mention is these rewindable spool cables. They're great. I love these. You can get these in like loads of different plugs, which didn't matter for me. I just got the European version and then I chopped off the plug. And also, when you're chopping off the plug, make sure you're holding the wire or you've got it like retracted, because otherwise it's gonna go right up in there, and then you're gonna have to open it up and be faced with a very angry spring that tries to decapitate you. Don't ask me how I know. For some reason, these were surprisingly difficult to find. It took me like a week before I stumbled across the search term that actually yielded good results. If you're wondering, it's automatic retractable power reel cable. For some reason, anything else, I didn't get good results. Those words in that order, your feed is now filled with them. The only real downside of these is that they are limited to 6 amps, which isn't really a problem. At most, I'm powering like an ESP32 with these, so completely fine. Also, it's 1.6 meters long. I have used this to like vacuum my office when the vacuum cleaner battery died. I just connected it, gave it 20 volts, like 5 amps, and vacuumed my office. It was fantastic. I'm definitely getting more of these in the future for more projects because they're just so nice and so useful. Like anytime you want to put away a cable, just done. I love these. Right, now before we continue, I want to show you the schematic for this so that it's a little less like this. Let's go over to the whiteboard. I'm at the whiteboard. Do you like spaghetti? Because that's what you're getting when I draw a circuit diagram. Luckily, it's not that complicated. We've got the power supply going into the 2 individual modules with some nice thick cables because I drew them thicker. And then we've got the outputs of which going to the banana connectors and the retractable cables. And then we've got the 2 UART connectors going to the Raspberry Pi Pico. Now, both of these also put out a 5-volt rail. Now, I don't know what the limit of that 5-volt rail is, and I don't want to suddenly find out with a puff of magic smoke. So instead, I use one to power the cheap yellow display and one to power the Raspberry Pi Pico and the individual rotary encoders. And so far, because I've had all the grounds tied together, I've not had any connection issues. Works great. I'm pretty sure I could tie the 5-volt rails together, but I'm not sure that's not going to cause a spontaneous rapid disassembly. So instead, I'm just not risking it and I'm powering things separately. But yeah, this works. It's not great, but it works. Most of the problems come from here, because the Raspberry Pi Pico handles all of the inputs and the communication with the individual modules. The cheap yellow display basically just displays stuff and makes it look pretty, and sometimes tells the Pico that I pressed the button. And yeah, this is the weakest connection in all of this. So I have updates planned, and for the most part, we are replacing this and some of this. I'm still going to have the Pico handle all of the inputs because it's great at that, but I'm replacing this and some of this with a Raspberry Pi Zero and a 5-inch LED touchscreen. This one specifically is from Elecrow. They very kindly sent it over to me when I asked, and it's specifically designed for the Raspberry Pi Zero. So I don't have my pins soldered on here yet, but theoretically it just clicks in here, and then you have a little HDMI to HDMI mini adapter which connects the two together. And also it breaks out all of the pins and shows you which ones are being used by the touchscreen. So theoretically the idea is that I connect all of the inputs and outputs, like the rotary encoders, to the Raspberry Pi Pico, because rotary encoders are surprisingly challenging to deal with because you have to keep track of time and stuff like that. So all of that will be handled by the Pico, and then it will just tell the Raspberry Pi Zero about what's being pressed and twisted and stuff like that. And then, because the Raspberry Pi Zero actually has 4 UART ports, it will talk to both of the power supply modules and, you know, just do everything I want it to do. So that's the main idea. Hopefully it works. And because I'm using a larger touchscreen, I want to have more features. I want to have like graphs and things like that. And there's other stuff that I can add as well, but I'll get to that later. First of all, I want to figure out how to get this to talk to these two and have like a very basic user interface so that I can actually press things and, you know, step by step figure out whether I can basically recreate the stack I already had. So step 1, UI, and talk to these two. I'll get back to you when I figure all that out. Okay. Good news, I got it to work. It was a little bit more challenging than I expected because apparently I hallucinated the information about the Raspberry Pi Zero having 4 UART ports. It just doesn't. So both of these are actually on the same UART port, which causes issues because first of all, they're both set to address number 1, so I had to change one of them. So this one is now address number 2, this one is address number 1. The second problem is that both of these modules set their TX pins high when they're not saying anything. So basically, when they're connected to the Raspberry Pi Zero, they're just shouting at each other and nobody is getting understood. So the way I fixed that is by putting diodes in line with the TX pins and then on both of the modules, and then adding a 2K resistor to pull the read pin on the Pico high. So it's a 2K resistor between the read and 3.3 volts. And that solved the problem. I can now talk to both of these individually. I don't have anything on the screen yet, but I do have a cool little command line tool that lets me address both of these individually. So if I can turn on one of the modules, if I spell it correctly, I can turn on that module. I can set the voltage to like 23, and then I can turn it off, and then I can switch to the other module and again turn it on and set the voltage to like 2 volts. If I spell it correctly again, like so, and I can turn it off. So it works perfectly. Next step is to figure out how to get the Raspberry Pi Zero to connect to the Raspberry Pi Pico with all of these knobs and switches on them. That's going to be a fun challenge because I don't know how I'm doing that yet. So I'm going to go figure that out, and I'll see you when it's done. Right, so things haven't gone well. Long story short, the Raspberry Pi Zero is dead, and this power supply module is also dead. I'm not 100% sure what happened, but I assume with the exposed wires I had and like the diode that's on the transmit pin, something shorted against something, and it basically released the magic smoke from this microcontroller that's for this power supply. I desoldered it because because it was just letting all the voltage through. So desoldering it stopped that, but it's such a bum. I had these buttons and switches working. I had the pico communicating with the zero, and things were working. I could control the power supplies, and then I like moved something to set up a shot, and it shorted, and there was a puff of smoke, and now the Raspberry Pi gets just very hot. It doesn't do anything, it just gets very hot. It's basically become a radiator. So that's fun, especially with summer coming up and everything. So I checked everything, all the other parts still work. I looked into solutions. I looked into whether I can just replace this chip. Theoretically, I could, but for some reason, it's more expensive than buying a whole new module. So I bought a whole new module. So I do have a second Raspberry Pi, which I think still works. So basically, I'm just gonna push on. I'm going to replace the Raspberry Pi. I'm going to test everything with just this module. I'm gonna make things neater so we don't have chaotic wiring all over the place and shorting everything out, and just wait for a new power supply to show up. It should show up in like the next week or two, fingers crossed. But yeah, so that's where I'm at. I'm not a happy boy right now, but I will press on. Okay, back to work. I wish I was setting it up so I could show you that these all work and everything, and like, So it seems that I've actually screwed up worse than I expected. I went away and I made the little PCB board for this. Like, it's got the Raspberry Pi Pico on it. I've got connectors for the rotary encoders and the switches. And then I got the Pico to talk to the zero, and that all works. So I got the switches working and all that. Then I connected the power supply module to like see if I can still control it and all that. And it doesn't come up. So after a little bit more investigation, see, I thought this power supply worked because the little display that it comes with, it still works, and I can turn it on and off, and I can set voltages and all that. Unfortunately, when I connect the UART port, it doesn't work. So it seems that I did actually fry the UART port on that one as well. So yeah, I've ordered a second replacement unit, but that's probably not going to arrive for a week or two. So this video is just going to be delayed, I think. Yeah, today is not a good day. I'm gonna go take the rest of the day off and reconsider my life choices till later. Okay, so it's been about a week since I last worked on this project, and today I finally received the new power supply modules. Yay! They work. It did take me a couple hours to set them up with the Raspberry Pi Zero, the Raspberry Pi Pico, the knobs, the switches and all that, mostly because I had to reinstall everything on the Raspberry Pi Zero from scratch, including the OS, the scripts, the Python files, the modules, the everything. It was a lovely pain in the butt. There does seem to be a slight bit of a difference between these modules and the older ones that I had. I mean, it has been a couple of years since I bought the original ones, so no surprise. But the head units don't fully work with these. They work in that I can kind of control the modules, but I have no idea what the display is trying to show me. It's like the segments that are supposed to be off are at like 80% brightness, so I have no idea what's going on. Again, I'm not using these in the main project. It's just I just use them for like debugging, so when I'm twiddling these knobs I can see what's going on. So instead, for me to actually show you that it does work, I can connect myself to the output of here like so, and I can turn on this module 6 volts or almost 7, and I can adjust the voltage there. I can adjust it down, and I can turn it off, and I can do exactly the same thing on the other side here. Turn it on, and again adjust the voltage just like so. So it all works perfectly. So next steps are for me to actually get the touchscreen involved and have some things show up on it. And then we can move on to actually making a box to hold everything together. Now, I've decided to slightly adjust how I'm going to interface with the power supply. So what actually happened is the new Ferrari came out and I was like, ooh. And what I took away from that is that the way I want to interface with it isn't through these knobs, because I don't actually really like them. They're nice and satisfying and clicky, but when it comes to like changing digits, it's kind of annoying because like this one will change the first digit, then you have to click it in and it changes the second digit, and then you click it in again and it changes the third digit. But what if I want to make minute changes fast without having to click the knob? What if instead I had a little toggle switch per digit? So I have voltage up, voltage down, and then the second digit, and then the third digit, and then the same thing for the amps. So basically I have 12 of these switches for each of the digits, so I can put them up and down. So that's 12 of these switches, and then I was like, cool, what am I doing about the on and off switch? Like these ones are cool, but like I don't think it's cool enough. So I went looking and I found these. They're little emergency stop switches. So I can twist them to turn them on, and then I can press them to turn them off. So it's very satisfying. So I've got a whole bunch of switches, and I've got 2 of these switches. So now, now I'm gonna work on the software a little bit, and then I can start working on the actual interface look, and then the actual box. And oh my god, I still have so much work to do. Okay, well, I'm gonna get to work. I keep telling myself that I'm not gonna work on weekends, and yet I still spend my entire weekend working on this. I've just been itching to get my power supply back. So I've managed to implement a little UI, which looks okay, and the buttons are also okay. For some reason, I cannot get the screen calibration right. It's a pain in the butt, and I don't know how to fix it, but I'm working on it. It's fine. It looks okay. And I've also implemented the switches, so I can now go up in voltage and up in... Oh, this one's backwards. Okay, I can fix that. That's fine. And same on the other one. Oh, this one's the right way around. Well, that's annoying. Okay, and now I can also twist this to actually turn on the power supply. So if I turn on my multimeter here, it's showing me 2.9 volts when it's supposed to be 3 volts. Okay, so there's a little bit of a mismatch. I can probably do some kind of calibration to fix that, but for the most part, it works. I can go up in voltages, I can go down in voltages, and I can even hold it to go up in voltages quickly and down in voltages quickly, or I can just press the stop button and it stops it. Beautiful. I'm happy. It's at a working stage. It's not quite perfect yet. There's still more features I want to add, but for the most part, it works. And I haven't released the magic smoke yet. And now I've also been working on the actual case for this, so let me show you that. Okay, so here is what I've managed to put together. Don't worry, it's not going to be pink. It's going to be whatever color I have the most of at the moment. These are going to be green, and this is going to be blue, and that is going to be red, just so I can kind of distinguish the 2 sides, right? And these are modular, so in the future, if I decide to like change the interface again, or if I want to add another button, I don't have to redo the whole thing. I can just redo that segment. I might add another connector here in the future for something like jumper wires, so I can just hook in and go into like a breadboard or something, but I'll deal with that in the future. These all kind of come apart, so if I lift this up, you can see that it kind of slides into place and then it gets screwed into place. I did have to slice the whole model in half because otherwise it wouldn't fit on my build plate. So I am going to have to glue those pieces together with some super glue, but it should hold together, specifically because the top part is also held together by the power supply. So that's going to be the power supply. This obviously has a break in it. And then we have the 2 power supply modules in here and my 2 rewind spools, which I did a 3D scan of. I've kind of figured out how to use the 3D scanner now. I'm still working on it. It's still a little rough, but I'm getting there. And again, these will have little spaces that I've not modeled quite yet to hold them at the right height. And yeah, I've left a lot of room in here still because I didn't model the monitor in here or any of the switches, so it does stick out a little bit, but also there's going to be a lot of thick wire going between the power supplies, the output and the rewind cables and stuff like that. So I've left myself enough room for all of that. So I guess with that, the next thing to do is just to start printing, and then we can finally assemble it. So to the printer. Welcome to my kitchen floor, where for logistical reasons my Prusa Core 1 currently resides, and it's probably no secret, I love this printer. If you're looking to get a 3D printer, get a Prusa Core 1. It is the best printer I've ever had. The camera, however, is a little bit and I don't feel like wasting a whole bunch of storage on 4K 3D print footage. So instead, just rest in the fact that everything printed beautifully, and I am satisfied with everything that has come out of this printer, except the time-lapse footage. It's great for like seeing how far along your print is and stuff like that, but for actual like video work, not really. All right, let's assemble this. I'm so happy with it. Like, I'm sure this is just me because I like designed it, built it, and assembled it and all that, but like, it just looked like, compared to the original, this is just a giant hunk of plastic, and this is like nice and sleek and refined and everything. It's just, oh, I'm so proud of this design. There is still more work to be done. There's 3 things I want to change in the future, not in this video, but I want to get this case reprinted on a bigger printer so that I don't have a super glue seam line down the middle, and also in a different color. This is just the color I had the most of at the time, and it's like way too close to this blue. I don't know what color I'm gonna go with, but leave your suggestions down below. Also, the power supply, I want to exchange it. This one has the fan just constantly on. I didn't want to use the same power supply from the first version because that one, I've never seen the fan turn on. I've even tried like using a hot air station on the thermistor to get the fan to turn on, and it just didn't, so I just don't trust it. So those 3 things I can change in the future. The last thing I need to do for this video is just software. Currently we are running Raspberry Pi OS, which takes forever to boot up, so I want to use something like Diet Pi so I can only install the libraries and things I actually need, and then have the software and stuff turn on automatically, because currently I have to SSH into it and then turn on the communication protocol between the Pico and the Pi, and then turn on the actual script, which is just way too long every time I want to use the power supply, and I don't want to leave it on the whole time because of the fan. So kind of a catch-20 here. So I'm gonna work on the software and then get back to you when I have more stuff to show you. 3, 2, 1. Okay, so I spent most of yesterday just working on the software side of things. So I've set up Diet Pi, I've installed all of my libraries, and now everything launches automatically. And that saves me about 10 seconds compared to Raspberry Pi OS, which isn't great, but at least I now don't have to SSH into it, and I'll take a 50-second boot up time it's just fine. I spent most of the day just kind of working on the actual UI and just making it look better. And I made myself a little Python simulator app that just completely simulates the power supply, so I can adjust voltages and amps and all that stuff, just so I can see how the UI reacts without me having to constantly upload it and check what's screwed up and then fix it up. So I'll leave that linked in the GitHub repository. And yeah, so far I'm really happy. There's things I want to change just because like the blue color of this line is too close to when this is on. It's just like it's a little too close. It's fine on this side because it's actually green, but yeah, I'm just not loving it. And obviously I can go up in voltages, I can go up in amps, and the motor spins and I can make it go wee. And I also have a little graph button which will just graph all of the power usage. So I can graph the amps, the voltage and all that, and I can turn it off and it does all that stuff. And there's room for me to add more. So like I want to have a whole row of buttons up here that I can, you know, add more features. Like my friend has a similar kind of power supply where he added a battery charger to his, so he can like configure how fast to charge it and things like that. So I might do that, but for the most part, I'm happy with this. It took way too long for me to actually, oh, maybe a reset button, because I end up having to go all the way down like that. Interesting. Oh, also I want to add like a hold to edit the preset button, so you can edit whatever voltage. So if you're working with like 7.4 volts, you can just have a preset for that. And yeah, there's a whole bunch of things I want to add. I'll have all of the code and stuff like that on my GitHub. So if you want to add some features and help me improve this for anyone else who wants to make it, feel free. Make a pull request and I'll see if I can figure out how pull requests work. But yeah, I'm happy to finally have this out there. Obviously it needs a little more detailed fine-tooth comb work, but I'm happy because it works and it's pretty much everything I've ever wanted. So I guess with that, thank you very much for watching. Don't forget to like and subscribe. Support me on Patreon if you can. Check out the GitHub repository and I'll see you on the next one. Goodbye.